This is the second section of the Chapter 4 unit test about rules of exponents, Form A. So in problem 4, we are being asked to simplify. And we have 5p minus 3q minus 3p plus 7q. And so to simplify this, I need to combine these similar terms. And I notice this term has a p, this term has a p, so I can combine them. If I have 5 p's and I take 3 p's away, how many p's do I have remaining? 2 p's. Thank you for not adding a crude joke. I also have q's. I have negative 3q, and I'm adding to that 7q. If I have negative 3q's and then I combine that with 7q's, what do I have remaining? Well, I have positive 4q remaining. Again, you've never heard the 4q joke? No, yeah. Say 4q quickly and you'll get the... If you slur them together, what does it sound like? Don't do it at home. They don't want you to get in trouble with your parents. Oh, now we get it. All right. All right. I also once had a kid. 2p or not 2p? That is the question. No. Okay. So moving on. So now this time I'm subtracting this binomial here. So if I have 5p and I'm going to take away negative 3p's, how many p's do I have? Well, subtracting a negative is the same as adding a positive. Therefore, 5p minus negative 3p is going to be equal to 8p. If I have negative 3q minus 7q, I'm going to go farther into the negatives on the number line, and so I'll end up at negative 10q. No joke necessary for either of those statements. All right, and number 6. I'm going to write it over here so I have some room. I have 2r squared times, or to the third power, times 3s to the third squared. All right, so order of operations tells me that I must do parentheses first. But inside these parentheses, there's not much that I can do because I have monomials. So then I have to look at the exponents. So I have to deal with this monomial taken to the third power and this monomial taken to the second power. So 2 to the third power is 2 times 2 times 2. And 2 times 2 times 2 is 8. R squared to the third power, well, this is equal to r squared times r squared times r squared. In other words, this is equal to r to the 6th. So I'm just multiplying these two exponents together. So I have r to the 6th. For this monomial, I have 3 squared, which is 6, and then s to the third squared. And using the same idea, 3 times 2 is 6. Oh. I'm sorry?
3 squared is 9.
3 squared, oh my goodness gracious. You're kidding me. I can't believe I just did that. I can't believe I did that either. Mr. Frankie. So 3 squared is not 6. 3 squared is 3 times 3, which is 9. So now we're to the multiplication. 8 times 9 is 72. I still have my r to the 6th, and I still have my s to the 6th. So therefore, this is my answer. And I can do nothing more to simplify it. In problem 7, I'm again going to need some more room because I have a bunch of steps here. So I have 3u, and this monomial is squared, times 2v squared w, and that's all to the third. And I'm going to subtract the monomial 12u squared times 3v to the 6th, w to the third. All right. Now, using the same ideas that I had in number 6, I'm going to have to deal with these this exponent before I do anything else, because I'm taking a monomial to a power. 3 squared is 9. U to the first squared is going to be u squared. Over here, we have 2 to the third, which is 8. I think we talked about that already. V squared to the third is going to be v to the sixth. And w to the first to the third power is w to the third. And now we're going to subtract that from this monomial that we have here. We have no exponents, so I'm just going to write it as it was originally written. All right, so now let's do my multiplication. 9 times 8, again, is 72. And I don't have any common bases here, so I'm just going to be left with u squared, v to the sixth, and w to the third. And I'm going to subtract 12 times 3, which is 36, u squared. I don't have any other u's here, so I'm just u squared, v to the sixth, w to the third. And oh my goodness, check it out. Right. We have u squared v to the sixth, w to the third on both sides. That means I can combine them because my variables are identical. Well, if I have 27 of these and I'm taking 36 of them away, how many do I have remaining? Well, 72 minus 36 is 36. And so I have 36 u squared v to the sixth, w to the thirds. And that is my final answer. Problem number 8. This time, I have some distributing to do. Better than some explaining to do. Lucy, you have some explaining to do. Okay, raise your hand if you get the reference that I just made. Oh, never mind, I can't see you anyways. All right, so we're going to take this monomial and we're going to distribute it to each piece of this problem. So 1/4 times 8 is going to be equal to 2. A squared times a to the first is going to be a to the third. B times b to the third is going to be b to the fourth. I'm going to cross that rainbow out because we've already taken care of it. So now we have 1/4 times -12, which is -3. A squared times a squared b, well, a squared times a squared is a to the fourth. And I have b squared, because b times b is b squared. And now finally, 1/4 times 4 is going to be 1. And like a good middle school student, I did not plan ahead, so I need to move it over. A squared times, well, there's nothing there, so it's just a squared, b, so I have no other b's. And now, do I have to have this 1 here? Well, no, because 1 times anything is always the other number, so I can just get rid of my 1. And the last thing I want to talk about is the ordering. Now, I am aware that I have said that the largest degree of the first letter of the alphabet must be written first. In this case, a to the fourth is the largest degree of this letter that is in that comes first in the alphabet. But there's a clause in the rules of writing mathematics that says that you do not want to start a mathematical number sentence, if you can help it, with a negative. And since this term is negative, we really don't want to have this in the front over here. So in this case, what we're going to do is we're going to leave it be. We're going to leave it in this case, which is why this problem had it ordered in this way. Another very common way of ordering things when you're going to start with a negative with the highest degree is to order it in reverse order. And that would have been okay too.
Did you get a student assistant?
We did. Ava Nelson. But I get her first. Sorry for you at home.
Next period.
Yes. All right. Finally, we have 3x minus 2 times x plus 4. 3x times x is 3x squared. 3x times 4 is 12x. Negative 2 times x is going to be negative 2x. And notice how I am stacking the terms with the same variables. Just makes it easier to combine. And negative 2 times 4 is going to be negative 8. So now let's add these together. 3x squared plus nothing is just 3x squared. 12x minus 2x is just going to be 10x. And I don't have any other plain numbers. I don't have any other constants. So I'm just going to have 8, negative 8 in this case. And so here is my answer. We will begin again on 10 through 13 on the third video.